We can use derivatives to help simplify the process of evaluating limits that take on the indeterminate form. Recall that if we are trying to evaluate a limit that produces a 0 over 0 situation, we typically use algebra or other kinds of algebraic manipulation tricks to put the function into a form we can determine the value of the limit for. 0 over 0 or infinity over infinity, these are both indeterminate forms that we can't make conclusions based off. Are they equal to 0? Are they equal to infinity? Are they equal to a real number? We don't know. Anytime we try to evaluate a limit and we see 0 over 0 or infinity over infinity, we know there's more work that needs to be done. The new way that I'm going to show you for evaluating these limits involves taking derivatives. So if we know how to take the derivatives of functions, then we can use this shortcut called L'Hopital's rule. First, we need to take into account that we've got a rational function that we're trying to take the limit of. And we can consider the numerator and the denominator separate functions. So the rational function we're looking at is f over g, our numerator function f, and the denominator function g. They both pass through the x-axis when we allow x to approach a. That means their outputs are 0 at x equals a. And if we use our knowledge of derivatives to approximate these functions very close to a, we can see that the tangent line that's formed is indistinguishable from the original function f. Only when we are very close to a, though, which is exactly what we're going to be doing because we let x approach a. Same thing for the denominator function. Very close to x equals a, our tangent line is a great approximator for our curve, g. So then, when we try to take the limit of this ratio, f over g, we can replace f and g with their linear approximations. Essentially the tangent line at the point A for each f and g. Notice that f of a and g of a are terms in these tangent line approximations for our functions, and we know that f at a and g at a are equal to 0. So this simplifies our expression a little bit, but also notice that now we have a numerator and denominator with a factor of x minus a that we can divide off. And so we see that using this linear approximation substitution for f and g, that we're actually just looking at the derivative of f at a and the derivative of g at a while x is approaching a. And this is the shortcut L'Hopital's rule. If you know that your limit has an indeterminate form of 0 over 0 or infinity over infinity, then you can take the derivative of your numerator function, take the derivative of your denominator function, and plug in a. Way less algebra to do it this way.